Good afternoon, Doctor. I'm Chung Jun Hung from Section 11. Today, I'm going to do a video on Assignment 1, talking about sorting. So, sorting is a process in which the data in a list are organized in certain order, either ascending order or descending order. So, sorting is categorized into two categories, which is simple sorting, also known as quadratic, and advanced sorting algorithm, which is also known as divide and conquer. So simple sorting algorithm consists of bubble sort, insertion sort, and selection sort. For advanced sorting algorithm, there is merge sort and quick sort. For bubble sort is a simple sorting algorithm that compares the adjacent elements in an array, sort the element according to appropriate order, then repeat the process until the array is sorted in either ascending or descending order. So this is the unsorted array given. So we will try to sort this array in ascending order. So at the first pass, we compare the first two elements. So since 29 is greater than 10, so 29 is swapped to the right. I compare 29 with 14, since 29 is greater than 14, 29 is swapped to the right. Then we compare 29 with 37, since 37 is greater than 29, and they are in a sorted order, so no swapping occurred. Then we'll continue comparing the adjacent elements, then swap them until the last element in the array. After that, we will carry on second pass, third pass, fourth pass, fifth pass, and sixth pass until the array is sorted with the same method and theory. So this is a sorted array: 5, 8, 10, 12, 13, 14, 15, 20, 29, and 37. Next, we have selection sort. Selection sort is a simple sorting algorithm that we will first identify the smallest or largest element in the array and place it to its correct place. Then we will repeat the process of identifying the next smallest or largest element in the array, then place it to its correct place, and the process is repeated until the array is sorted. Since we need to sort our array to ascending order, so we will choose the largest element in the array, which is 37. Then is swapped with the last element in the array with 15. Then in the second pass, we will choose the second largest element in the array, in the unsorted array, which is 29. Then we swap 29 with the second last element in the array, which is 12. Then same process is carried out for the third pass, fourth pass, fifth pass, sixth pass, and seventh pass until the array is sorted. So this is the sorted array. After that, we have the last simple sorting algorithm, which is the insertion sort. In insertion sort, we will first partition the array into sorted and unsorted regions. After that, we will take each item from the unsorted region and insert it into its correct order in the sorted region. So since 29 is the first element in the unsorted array, so 29 is considered as the sorted region, and the rest are the unsorted region. So first, we will take the first item from the unsorted region, which is 10, and insert it into the sorted region. Since 10 is smaller than 29, it's inserted to the left of the sorted region. After that, we take another elements from the unsorted region with 14, then insert it into the sorted region, which is according to the order. After that, same process and same step is repeated until the array is sorted. So this is the sorted array using the insertion sort. After that, we have our first advanced sorting algorithm, which is merge sort. So in merge sort, we will first divide the array into halves, then we will sort each half, then merge the sorted half into a sorted array. Okay, since the unsorted array has 10 elements, we will first divide it into two halves, with each has 5 elements. Then we will divide each half into another half in the another two half, which one has 3 elements with another has 2 elements. We will divide the halves until there are only one item left, which 29, 10, this one item left. After the dividing process, we will start the sorting and merging process. So we start from the left. First, we will sort 10 and 29 and then merge it. Then we will sort 14 with 10 and 29 and merge it. After that, at here we will sort 13 and 37. Since 13 is smaller than 37, it's put at the left. After that, we will sort this half with this half and then merge it into a half with 5 elements in the sorted order. And we will do the same for the right section. And after doing the process, we will get another 5 elements with sorted order. After that, we will combine these two halves by sorting the element inside with correct order, then merge it to form the final sorted array, which is this. Finally, we have the second advanced sorting algorithm, which is quicksort. So for quicksort, first we will choose a pivot, which usually is the first elements of the unsorted array. Then we will partition the array around the pivot by placing the pivot in its correct position. Then we will sort both left and right section and dividing it until there's only one item left. At here, 29 is the first element of the unsorted array, so it is the pivot. So for the first step, we will find the first item from the left that is more than pivot, which is 37. After that, we will identify the first item from the right that is less than the pivot, which is 15. Then we will swap the position of these two elements. After that, we will repeat the same step, find the first item from the left that is more than the pivot. Since that is no, then we will proceed with the next step, which is find the first item from the right, which is less than the pivot, which is 12. Okay, since there's no first item that is more than the pivot from the left, we will swap the pivot with the item from the right, less than the pivot. After the swapping of the pivot, we will divide the array into two parts, starting from the pivot here. Since 37 is left as 1, so there's no sorting here. We will see the sorted array here. So we do the same process. So set the first element as the pivot, then find the first item from the left that is more than pivot, which is 14, then less than pivot from the right, which is 8. Then swap their position, do the same process until there's no item from the left is more than the pivot, and then we swap the position of the pivot with the first item from the right that's less than pivot, which is 5 here. Then we will divide the array starting from the pivot here, and then carry on the same process with same theory and methods. And finally, we will get a single item left, single element left. When we get the single element left, it is in order, which is 5, 8, 10, 12, 13, 14, 15, 20, 29, and 37. So this is how we do the quicksort. So that's all from me. Thank you.